Hi everybody and welcome to the Mangano Digital Academy. Today, in this short lecture, we will talk about the accuracy in the full arch digital implant impression because it's one of the most important and hot topic in digital dentistry today. And I think it's very important when talking about digital implant impression to consider the different factors that may affect the final results and the final accuracy of the workflow. And these factors are these six factors, the main factors are these six here in this slide. First of all, we have the intraoral scanner, of course, the device we are using because the devices have different intrinsic accuracy. So it's very important to choose the proper device. And then, of course, the operator factor, because the operator plays a major role with the scanning strategy that must be the right scanning strategy for that device, and also with the experience and the skill of the operator. The patients as well is very important because the number of the implant, for example, the inclination of the implants and the depth of the implant can have an influence in the final results, and the literature say and support this concept. Then the environmental condition, for example, the light condition may have a role and they can affect the final results. And one of the most important thing is the scan body, of course, because it is not merely a transfer of the implant position like it was during the analog impression. Here it is more because the design, the material of the scan body, the tolerance in the manufacturing of the scan body, the position when we screw it, the torque are very important. So, I mean, they can affect the final quality of the impression, as well as the lack of congruence between the mesh of the scan body and the library file. We are all aware of the fact that the dental technician receives mesh from the dentist and has to change the mesh of the scan body with the corresponding library file, and this corresponding library file is linked and coupled to all the different components of the library where the dental technician models, like for example the T-bases and these links. So it is very important also to have a congruence in this moment during the first phases of the computer-assisted design. But in this lecture, we will focus our attention only on the first element, so the intraoral scanner. So we will talk about the intrinsic accuracy and the accuracy of the intraoral scanners. So this is the factor, this is the number one factor to be considered when capturing a full arch implant impression. And we need to go back to the basics because the intraoral scanner works so they emit a source of light, it's usually structured light, a structured light grid or pattern or laser, and then this grid, this pattern of light undergoes deformation because of course when we emit this source of light, this light impact on the scan bodies and the model, then there's the deformation, and this deformation is captured by the cameras of the intraoral scanner. The software makes the work and the magic, and it creates a point clouds, and then these point clouds are triangulated into meshes. So the mesh is the final results of the acquisition, and it's a reconstruction of the surface of the object. And obviously it is a geometric approximation of the object, and these geometric approximations come from the element of triangles, because the more triangles we have, the more the object will look natural, but anyway it is a geometric approximation because these points are triangulated. So the element, the basic element of this file is the triangle. Usually they use triangles, and the polygonal mesh. So it's the final results of our scan. It's the reconstruction of the surface of the object. It's a schematic approximation, a geometric approximation of the object. And as I told you, the more triangle we have, the more point clouds we have, the more dense is the net of triangle, and then the object look really natural, but anyway it is a geometric approximation. And the Nurbs file, for example, is something different. It's more similar to the library file used by the dental technician because It is a file that is perfect, controlled by point, construction point, non-uniform rational basis spleen, but it's only an example of something that is more similar to the library file. The format is the same, maybe it's saved in STL as a stereolithography on standard tessellation language, but the appearance is totally different. In this video you see that if you take a look of these files, they look similar, but if you go closer, if you look with attention, then you see that the mesh is a geometric approximation, because there are a lot of triangles and you cannot see the tiles perfectly, for example, with the angles, and it's a little bit, it's a triangulated surface, so everything is smooth. We don't have a sharp situation in this file, because it's a mesh, it's an approximation. It's very important to keep in mind. The dental technician changed this mesh, the mesh of the scan body, with the library file, and then we obtain an hybrid file, because the dental technician modeled the final restoration or the provisional restoration on the library that is inserted on library components that are inserted in a mesh, so the arch. So it's very important to consider this very important moment, the moment in which the mesh, that is a geometric approximation of the reality, the mesh of the scan body, is replaced by the library file, the original CAD design. And so this file is coupled with all the library. It's very important, and it's here in this short video you see an example. Basically the dentist sent to the dental technician some STL file, the master model with the mucosal color, the antagonist, and then the master model with the scan body in position. It is a mesh. Then the dental technician replaces only this mesh, only the scan body mesh, with the library file, the corresponding library file. And it is quite important, because we have much more definition, and the dental technician can model on perfect margins, but it's very important that the position is the same. So we have a superimposition first by point and then with the best fit algorithm, and the dental technician can model the restoration, can choose the different bases, and there are a lot of different solutions, but the final model, it's a hybrid model, because we have a mesh, but the technician is modeling the restoration on the margin of a library file, library component, so everything is perfect. It's not a geometric approximation. It's very important to say this. And when we talk about intraoral scanner, we talk about several features that must be considered. One is the accuracy, of course, the trueness plus precision. Then we have the resolution of acquisition. I told you the number of triangles. It's very important, this resolution of acquisition, particularly when working on natural teeth, but when we work on implant it's less important. I would say that accuracy is much more important in implant prosthodontics. And then we have all the clinical features that are also very important. The color, now more or less all the scanners have natural colors. The speed is also very important. We need to capture the full arch as fast as possible. The size of the tip, the possibility to export the file in different formats, also open formats. All these aspects must be considered, but the accuracy is the most important thing. And inside accuracy, trueness is the most important thing. And when we talk about precision clinically, we refer to the clinical precision, so the margin of the restoration, how the restoration adapts to the margin, the marginal gap. And from the Bibles of prosthodontists, we see that the most important authors say that ideally this marginal gap should be compressed between 25-30 microns. Some other authors say also 50-100 microns. But anyway, it's something clinical. It's a definition that is a clinical definition. And if you look at this definition, it depends not only by the scan, but it depends also by the way you fabricate your restoration. You mill or you print your restoration. So this definition does not apply to the intraoral scanner. When we talk about intraoral scanner, we talk about accuracy that is made of trueness plus precision, and precision has a different meaning. It's the repeatability of the scan, so the quality of the scan. So the ability of a measurement to be consistently repeated. The trueness is the most important thing, is the ability of a measurement to match the actual value of the quantity being measured. So we need both in order to have an highly accurate scanner, and trueness is the most important thing. So we need to have a scanner that is extremely true and precise, because it has to reconstruct the object exactly, the surface of the object exactly as it is, in a very consistent way, without any error, any mistake. And when we look at the literature, we see that the only problem with implant prosthodontics is related to the full arch, apparently, because most of the literature review says that intraoral scanners are not sufficiently accurate for capturing optical impression for the fabrication of long span restorations such as the full arches. And so my study, recently published in BMC Oral Health, the journal I'm editor in, had to deal with this aspect, very important aspect. What is the best scanner in full arch implant impression? Because intrinsically we know that the scanner is a factor. Intrinsically different scanners have different errors, as evidenced also by other studies in the literature. And so I wanted to investigate today what is the best solution that we have for the full arch impression, at least for the factor 1 of the list of 6 factors, the intraoral scanner. And so we tried to compare and evaluate 12 different intraoral scanners. It was a comparative in vitro study for the full arch. These were the scanners that we have investigated: the iTero Elements 5 from Align Technology, PrimeScan and Omnicam from Dentsply Sirona, CS3700 and CS3600 from Carestream, Trios number 3 from 3Shape, then Medit, then Emerald and Emerald S from Planmeca, Virtuo Vivo and DW10 from Dental Wings, and Ranai's Quick Scan, the last one, a Chinese scanner. These 12 scanners are totally different from the perspective of the technology of acquisition, the output file. Of course we are comparing machines that use structural light, sometimes laser, so different technologies. But we wanted to understand what is the more suitable, what are the most suitable devices for the full arch impression. So Uli Oshi and my friend, dental technician, prepared this beautiful model with Megagen implant component. In this case we are talking about the AnyRidge implant system, 6 scan bodies, 13 mm 8 in PIC. And we prepared this model, and with different positions. This model was scanned by a very powerful desktop scanner as a reference, in order to obtain reference files, like we did in previous studies. We obtained reference files to compare the files captured with the different intraoral scanner. So this was the design of the study: data acquisition. We captured some reference scans, we validated them, we selected one reference model, virtual model, and then I captured in person 10 different scans for the full arch with each of the intraoral scanner investigated in this research. So a total of 120 meshes that need to be compared and superimposed to the reference file in order to understand the overall trueness. So the trueness was the main outcome variable for this study. And obviously it takes a lot of time to capture all this impression. I followed one specific scanning strategy, a zigzag technique, starting from the buccal, then moving occlusally, then palatally, then back to the occlusal and the buccal, moving slowly forward, trying to capture all the most important elements of the pink gingiva, including the scan body as well. The operator was only one, it was me, and all the scans were taken under the same environmental conditions, so the same light condition, the same temperature, humidity, and they were also randomized in sequence in order to the final result not to be affected by the operator fatigue. And the second part of the study also took a lot of time. It was the moment for the superimposition of the files, and we used two different distinct techniques. We used a mesh-to-mesh approach, directly superimposing the mesh, so the reconstruction of the surface of the object from the intraoral scanner on the reference file. The reference file, once again, a mesh, and it was the first evaluation, a very direct way to evaluate the quality of the scan, of course, as an overall trueness parameter. And then we also applied a new method that I call it here Nurbs to Nurbs. In real, it is a little bit more complex, but it helps more because it is like more connected with the normal workflow in implant prosthodontics. Basically, we took each single mesh from the different intraoral scanner, and we replaced within each one of these meshes all the library files inside. So we had at the end for every single scan the position of the 6 library files of the scan body in the space, and we superimposed this 6 position over the 6 position taken from the reference file. It's much easier to show you how it works. This is the Nurbs to Nurbs approach, as you can see. So we have 6 library files here, the reference positions, and 6 library files here, the scan body, and the scan body position are superimposed on the reference file by means of a point and by means of surfaces with the powerful superimposition algorithm of the software. So this is the Nurbs to Nurbs, and we generate a colorimetric map that gives you idea of the distances. Green means less than 30 micron per each single point, and blue means more than 30. And here it's another video in which I show you the mesh-to-mesh approach. As we can see, we are not dealing with library file directly, we are dealing with the meshes. So we superimpose the mesh directly taken from the intraoral scanner to the mesh captured with the desktop scanner. So it's a more direct method. Even here we can work by points and then by surfaces using the best fit algorithm, and then we can generate the colorimetric map, and it's more or less similar. The method is similar, and the results are very interesting, because we can evaluate also deviation at 1 micron deviation, so it's very sensitive, the tool we are using. So this was the mesh-to-mesh evaluation. This was the table at the end for the two kind of evaluation, mesh-to-mesh and Nurbs-to-Nurbs. We are talking about medians and means and 95% confidence interval. And as we can see, we have different results for the different scanners. Here the visual representation of these results. As you can see, we have the error is slightly, less with the Nurbs to Nurbs approach, and its logic. And we have more or less 3 categories of scanner. The best scanner for the mesh-to-mesh is the CS3700 from Carestream, but very close to that we have iTero Elements, Medit, CS3600, and Trios, and PrimeScan as well. More or less the same results with the Nurbs to Nurbs evaluation, but with this latter evaluation we have lower values, because the method is more similar to what happens during the normal workflow in digital prosthodontics. We superimpose only positions. And this is the schematic representation of the error. So the overall trueness, mesh to mesh. Here the error is distributed along the whole arch, because the method distributes it along the whole arch. As we can see, we have excellent results for the Carestream scanner, the Align scanner, the PrimeScan from Dentsply Sirona, and the Trios, and also Medit works very well. The other scanner have higher errors, And if you watch it in a logarithmic scale, this is the representation. If you see superimposition between the red arrow, it means that there's no statistically significant difference between the different scanners. Here the representation for the Nurbs to Nurbs, more or less the results are similar, but very interesting that one scanner is less than 20 micron error in the full arch as a mean. In this case, iTero Elements 5D, and then we have all the other best scanners following him with very little differences. And as you can see, we have 3 groups of scanners, and the first group is composed by iTero Elements, PrimeScan made it, Trios, and the 2 Carestream scanners that perform much better than the other, also in the logarithmic scale, as we can see here. And if we go on, we see that the nerves-to-nerves evaluation overall gives better results than the mesh-to-mesh evaluation, but we expected it, of course it's natural. And in this table you can see on the top of the table the differences between the couples of scanner, and on the left and bottom of the table the p-value for the statistical analysis. And if the p-value is less than 0.05, it means there's a statistical significant difference between the different scanners in the mesh-to-mesh overall trueness evaluation. And here the best results with the mesh-to-mesh, as we can see, we have excellent results, and the results are also dependent by the operator, by the moment, by the capacity to be stable and the progression and consistent. And the results are very good for all of the scanners. And as we can see, the green is prevalent, and if we go to the nerves-to-nerves evaluation, it's even better. We see once again on the right top of the table the difference between the couple of scanners, and on the bottom and left the p-values. Once again we can evaluate if there are statistically significant differences between the different scanners. And here we see the best results obtained among the 10 scans per each scanner, and it's amazing, for example, the results obtained with the CS3600, because we have only 9 micron of mean error. It's very little. I mean, the intrinsic accuracy of the scanner during this scan was amazing, less than 10 microns, and we can evaluate it. And also other scanners have very low values, so low errors, and it's something that we couldn't imagine even 2 or 3 years ago, because the technological advancement have been amazing in this field. But we didn't consider only the overall trueness. We consider also the linear measurement, because we wanted to check exactly the distances between the different scan bodies, because we are aware of the fact that the overall trueness gives an overall idea of the trueness, but we need linear measurement, because without linear measurement we cannot assess completely the fit of the final restoration. So we took the positions using the library files of the nerves-to-nerves approach, and we computed the distances between them at their centroid at the base. And using another software, in this case Magix from Materialize, before we use a GeoMagic. And we compared simply these results, the results of the reference file taken from the desktop scan, and the results with the different intraoral scanner. And once again, here are the results with the medians and the means, plus the 95% confidence interval. And I want to point out that once again we have a group of scanners that are considered the leaders, in which the linear distances, that are the distances across the arch, during the scan, during the progression of the scan, so S1, S2, S2, S3, S3, S4, S4, S5, they are of course limited, particularly in the first group of scanner. The distances become wider and huge when we consider the cross distances, that are the distances from the right to the left. So for example, we computed the distances between S1 and S6. It's much more tricky for the scanner to calculate exactly and to represent exactly these distances. And of course we expected to have a huge error in this, but once again we have 3 groups of scanners for the performance, and the best group anyway have consistent results. So once again the table, local Trueness linear distances, and we see the different distances with the different scanner. We can compare a couple of scanners, for example, in order to understand at the bottom and left of the table, for example, if there's a statistically significant difference between them. And here the graphic representation, and once again, if the red arrows superimpose each other, there's no difference statistically in the quality of the linear measurement. Here we see the cross distances, the most difficult to compute, of course, for the scanner, the most difficult to represent for the scanner. And here, of course, we have higher errors, but once again, 3 groups of scanners, as we can understand from this evaluation. And here the medians and the median absolute deviation from the median, other values that we can compute from this huge amount of data. It took months to create this work and this big research, and a lot of superimposition and many different computation. As we can see here, other graphics that represent the different situation with the median linear distance and the median with the cross distances. And so we had the conclusion of this study. The conclusion are this one, basically. We have statistically significant differences in trueness between different scanners. And I would say that there are some scanners that are more suitable for the full arch application, like the 2 Kerstin scanner, 8 hero elements, prime scan, made it, and Trios 3. They looks more suitable for the full arch implant impression. So there may be a specific indication for use this scanner in the full arch impression because they are intrinsically better than the other in this specific application. Of course, there are different results with the different evaluation method, but it's less important. There are limitations in this study. It is an in vitro study, and of course we don't have saliva, we don't have the movement of the patient, the humidity. The condition of the lights are totally different. In the mouth, when we work on a model, is different, but it's impossible to have a reference absolutely reliable in vivo. The scanning strategy is also maybe a limitation because we choose one scanning strategy, we applied for all the scanners, but maybe some of the scanners they require another strategy. We use the desktop scanner as reference and not an industrial scanner, but it's not a main limitation because this scanner is very powerful and of industrial origin. And maybe the 0.5, the scan progression, because we didn't start all the time from the left or the right. Sometimes we start from the posterior left, sometimes we start from the posterior right, and we lost the opportunity to calculate how the percentage of error increased during the scan. It is a consideration that we will use in other studies. So, this is probably the recipe for success when scanning full arches. The best thing is to choose proper devices that allow you to be safer because they have an intrinsic accuracy in nerves to nerves that is less than 20 microns, for example. And the scanning strategy is very important, the operator is very important. I suggest to use intraoral digital impression with intraoral scanner with 4 implants. If the implants are 6 or more, we can maybe consider the opportunity of using a solid index technique or photogrammetry. We will talk about these techniques more in detail in the next lectures. This is the paper published in BMC Oral Health. I invite you to visit the page of the journal. You can download all the articles for free and you can read without paying nothing. It's an open access journal, Q1, with a 2-point of impact factor. And I also invite you to visit the website of the Mangano Digital Academy and to follow us in YouTube, Facebook, Instagram and Twitter, because we will publish a lot of things related to the world of digital dentistry. Together with our partner and tools, we have software and tools that we love to use, and we will publish a lot of contents about these tools and softwares. Thank you very much for your attention.